look at my notes, tell you I'm Jason Marshall of Jason's Space Dock, and thanks for coming out today. The whole purpose of this talk is to make lighting as simple as possible. Part of the reason is I get what I hear a lot from other builders, fantastic builders, is they don't do lighting because it's intimidating, it's scary, I don't know where to start. A lot of times, they get the advice like, just Google it, go to YouTube or whatnot. Well, that's fine, but there's 10,000 links to choose from, so where do you start? So we're gonna go over the components, over the basics, so that at the end of this, you should be able to light up an LED. And I've got a table outside, but I brought these guys in as well, just to really show, well, here, lighting, just, it's an additional step, an additional detailing piece, like weathering, photo etch, whatnot, that just helps bring your models to life. And I will say this, once you get the basics down, once you try it, there's going to be a whole realm of interest and excitement of trying different things. Like I talked to, sorry, what was your name?
My name's Eric.
Eric. Sorry, I'm going to forget that. I'm terrible with it. So, for example, all these have different types of lighting in it. This uses a combination of fiber optics and a single blinking LED versus a flasher board or whatnot. This is primarily all fiber optics, run off a few LEDs. This guy has a strip of LED tape inside to light the floor. This is kind of a combination of everything. Same with the Kelvin. Now that's getting ahead of myself as far as what you can use, but it just fire up your imagination a little bit on what your possibilities are. And as I said, what I usually hear is that looks complicated, I'm intimidated, whatnot, but once you understand the basics, and I know I'm repeating myself a lot here, how LEDs work, how to power them, how to control your voltages to keep them from burning out, you're going to be good to go. And trust me, I've burned out my fair share of LEDs getting started. But like weathering, pre-shading, post-shading, whatever, you don't get it overnight. It takes time to get into it. But the payoff is absolutely worth it. And as I said, you'll find out, I don't want to say use specific words, it's easy, it's simple, because in my, we'll call it day job, I suck at caulking. And everyone I work with, like, caulking's easy. I'm like, well, it's not for me. So I don't want to use that specific language. But the good news is that you don't have to be a mechanical engineer to get the basics once we go through it. You don't need a whole bunch of expensive gear or expensive tools either. Once you get the fundamentals, so you can light practically anything. So we'll start with tools. And I'll have pictures on here. I've also got my kind of tool set over here, so you can look at it, photograph it, write it down, whatever. But as far as simplicity goes, my go-to is this $50 soldering iron from Canadian Tire. It's never, the last one, I'm actually on my second one. The first one lasted 15 years. So, hello. You didn't miss much. I just kept saying over and over again, I'm going to teach you how easy lighting is. Helping hands, I've got two types up here. This is kind of the standard one, but the idea is, you run out of hands, so you can use them to hold two wires together so you can do your soldering. Because of my age, I've moved to the other one with the magnifying glass. wire strippers, and it's a little bit of both, strippers and cutters. But I'm going to get into that a little bit more because I've used some wire that you can't use strippers on. Side cutters are good to have because even though the strippers do have a cutting option, it's down here near the pivot, and if you know your tight space, you want to be able to get in there. So a second pair of nippers is handy. Breadboard, this is a bit more, actually, I don't want to say it's more advanced. This is a way to practice circuits and lighting without actually soldering anything. You apply your power, jump it to here, put your LED in and your resistor, and basically test things before doing anything permanent. It does help you get your head around it. I did add a multimeter, although I never used mine. Because generally the voltages are so low, you're going to be working by and large, if you do lighting, with a fairly small set of components based on voltages and what you want to accomplish. So you'll find very quickly that, you probably don't need it, but it is a good tool to have if you ever need to check anything like resistance, or if a component has failed, if you're trying to diagnose something that doesn't work. I didn't show them here. Tweezers also help, but I assume as modelers, most people have that as part of their kit anyway. But like I said, I've got all these up here as well, so you can actually, besides a picture, you can actually see what tools I use when I do my own lighting. Once you're past tools, basic materials, and this is what I was saying, flux core solder. The flux is what allows the solder to flow when you heat it, so it flows into the joints you want, or if you're using multi-strand wire, it penetrates all the way through. But I use two different types of wire myself because of small space. One is magnet wire. This is actually very, very thin. It's resin coated. Now, a lot of people online use their soldering iron and solder to strip the resin coating on. I've never been able to do that. I watch people do it, I can't do it. So I use a torch and just burn a little bit off. My other preference for small is wire wrapping wire. So it is a single strand, similar to the magnet wire, but this is where you can actually strip off. What gauge is that? There we go. Strip off that. I know you can't see what I'm showing you right here, but I'll have it up here. But you can strip off your insulation very easily with your wire cutters. Heat shrink and liquid electrical tape kind of go hand in hand because you want to make sure any of your exposed solder joints, not so much on your LED leads, but throughout the model are covered and insulated. You don't want anything touching and shorting things out after you close it up. And I just put the hot glue gun, because that's kind of my go-to for locking wiring and components inside a model. But you can also use, which I have used, clear UV resin and a resin light, or a UV light to cure it. It's another good way to lock things down. Am I going too fast for anyone? Okay. Don't be afraid to say if I am. And I haven't done a lot of presentations. And as you can see, I got a couple boxes of items here. So everything I show on screen is going to be here, so you can actually look at it, you can see it, you can touch it. But there's a number of different components. These are my go-to forever, your basic round LED. 3mm, 5mm, but they also come in an assortment of others. Rectangular, if you need a flat spot. They've got a long lighthouse one, a little short one, a big fat one, depending on what you need. And their intensity is very, very, very bright. Then you have SMDs, which are more and more the go-to now. It's really just the diode, the light-emitting diode itself, with wires attached to it. Comes in several different sizes. There are more interesting things now. I'm going to touch with this first. The old LED tape, which is similar to that, it's just diodes on a strip, which is great for general lighting, but for example, it can leave hot spots, which is, you get, where the spacing is just too far apart, and that's where chip-on-board tape excels, because it's a ton more and they're close together, so it's a very, very consistent light, so then you get proper glow. Depending on what you're trying to achieve. If you're lighting windows and say, like, lighting a group of windows, it's not too much of an issue because of how light transmits, but in the case of Star Trek in particular, those warp engines are hard to get right. But there's even more components available now. I have been using these. These are a rigid LED, just a long diode. I'm sure you've seen them in the Edison bulbs they do now. So it looks like an old classic light bulb. So that's basically what those are. And there's a variant which is also the flexible kind. They all come in different lengths and whatnot, depending on your needs. But the amount of components available now versus when I started lighting models in 2012 is, and man, I wish that stuff existed then. Okay, everyone's good? Like I said, don't be afraid to stop me. And here's where I'm not going to look at you while I read my notes. So why do we need resistors? A resistor limits or regulates the flow of electrical current in a circuit by introducing a property called resistance. Measured in ohms, and when we talk about resistors, they are measured in ohms, 22, 470, 20,000 ohms, etc. But this is it took me a while to find this. I can only find a low-res image of it. But it's a funny little drawing that is basically, if you think of electrical current like water through a pipe, the power supply, which your voltage is going to vary, is your water pressure. The current is the flow of the water, and the resistor is the narrowing pipe that keeps the flow under control. Now, without the resistor, if you just powered an LED with 12 volts, it's going to burn out. It can't handle that voltage, and that's ultimately, pardon me, I skipped ahead, but that's where Ohm's law comes in. It basically means that changing one changes the other. Everything is intertwined. I don't expect you to memorize that, because it's actually surprisingly beyond knowing the resistors are rated in ohms. You don't necessarily need to know it for, this particular lighting. And then, of course, as I said, resistors are a big part of lighting to make sure you don't burn out your LEDs. I've put this here, but I'm going to leave links at the end because there are resistor calculators and charts on how to read resistors. Now, most of them, when you buy them, they're going to come labeled, but if you ever find a stray one, you don't have to remember all these numbers. I went to school for electronics assembly. I can't look at a resistor and read it without a chart, because it has never been an issue. But I did want to put this here because it's important to know that everything has a meaning. So whether it's 4, 5, or 6 band resistor, the first few are your number. So I'm just going to go through this. So the first 3 bands in this case of a 5-band resistor are the number. Then the 4th band is your multiplier, and then the 5th band is just your tolerance, up or down percentage-wise. I'm kind of going through this very quickly because it's not the, sorry, let me use appropriate language. I don't want to say it's not any less important than anything else. It's more like, I'm going to show you how to do the calculations, so you don't necessarily need to know and memorize all this. Just, there's a basic overview of why they're printed the way they are. And as I said, in practice, most times you're only going to be using a select few resistors anyway. Now, for example, most of these, because I tend to run a 9 or 12 volt system, everything's run off 470 ohm resistors, so I've got a big supply of that. If you change the voltage up or down, you'll need a few more, but more and more, sorry, pardon me, not more and more. I apologize, I got off my script. Once you get to the end of this and understand how to calculate them, there's only going to be a handful of resistors you're going to have in your kit. If that may be a better way of saying it. Okay. Now, everyone bring their scientific calculators? I want to put this up because this is, you know, your big, you go online, it's like, this is how you calculate things. I'm going to break this down for you much simpler. But when we talk about Ohm's law being one value impacts every others, basically resistance equals source volt, so voltage source, so that's why it's Vs. And the resistor, the LED, they call it forward voltage. I didn't look up why, and we never actually talked about it in school. But in the case of these, for example, I've got 12 volts in, or 9, these might be 9 volts. Anyway, it's actually the same resistor for 9 or 12. Run 9 volts in, LED runs on 3 volts, so I've got 6 volts left over, which I have to divide by the current, which is milliamps. This was just for fun, because we're going to go much simpler now. And I'm going to go the right way in my slides. Hope you like the AI images I had generated. So like I said, basically, here's everything in one shot. 9 volt power supply, 3 volt LED running at 20 milliamps, which seems to be consistent. With the SMD ones, the pre-wired ones, oftentimes when I get the product, it doesn't list milliamps, but it's generally accepted they're running at 20 milliamps, just like regular LEDs are. But as you buy products, these are a piece of information you're going to look for as you get them. So to get my resistor, 9 volt minus 3 volt divided by 0.02, which is 20 milliamps, gives us 300 ohms. Now I'm going to go over that again, one slide at a time. So once again, supply voltage at 9 volts minus the 3 volts that your LED runs at, which is most LEDs. Colored ones do run differently. Reds, blues, I believe, tend to run about 2 volts. So, but once we get through this, it's not going to be a problem for y'all. So our voltage drop is 6, so we have 6 volts we need to eliminate. Then we take that 6 volts and divide it by the current that the LED runs on, which, as I said, is 20 milliamps, which leaves 300 ohms. There is not a 300 ohm resistor, so you're the next size up. And that is basically your calculation whenever you're doing LEDs. It is literally as simple as that. But the best part is, same thing, you don't have to memorize this. I'm going to give you a link to a calculator so you can just punch the numbers in. And yeah.
I've got a question, if you don't mind.
Yeah.
In this case, you've gone with 330 ohms for the resistor. Mm-hmm. Are you, I don't do electrical stuff.
Yeah.
Are you purposely going high? Like if let's say you have the option of a 270 ohm resistor, would you not go for that because it's too low? Would you always go on the high end of the resistor?
I always go on the high end. The potential is that a lower one will probably be okay because it's going to depend on its tolerance. That was the last band on, like sometimes it's 1%, sometimes it's 5%. That is something to take into account. I always play safe and go high. Because the amount, the ohm difference between 300 and 330 is so negligible, it won't impact the intensity of your LED. In fact, if you need to make your LEDs dimmer, you can add more resistors into it. Now, I haven't done that, so I don't know the calculation for it. But it is a possibility depending on what your needs are. Of course, there's also additional components, variable resistors, basically the volume knob on your radio, same idea. You can use that to control intensity. But because it's something I never have a need for, I haven't looked into it.
What if your LEDs are in series? You want to string about 4 of them. Do you have to put one resistor for each different value?
That's actually what we're going to talk about, is series versus parallel. Because you do have options. Generally, though, skipping ahead, 1 resistor per LED is the way to go, so you don't have circuit failures. Because it really comes down to old Christmas lights. If y'all remember the old ones that as soon as one light burned out, the whole thing goes out. So, as I said, you have a couple options. Series, where everything is chained together. But if one LED goes out, and parallel is each LED has a path to power versus a shared path. So, if one fails, everything else stays lit. And as I said, old Christmas lights versus new Christmas lights. Excuse me, I apologize. So, but as far as, to give a fair and balanced argument, with series lighting, you do have fewer resistors, less wiring. Those are, and if you're in a really tight space, it is something to consider. But of course, you need a larger power source because you're limited by the draw in a series circuit tends to exceed a parallel circuit. And as I said, one component fails, they all go out. And so I'm just going to, repeat the same thing there. Your power passes through all the components. One failure equals all failures, which is hard enough to diagnose when you haven't sealed your model. And then parallel, which, I would recommend anyway, is, you're going to need, you can run more LEDs because of the nature of the circuit. Your power supply, the amount of components is only limited by the output of your power supply. So once again, this is a thing that you would look at in the future, but you can buy a 12-volt power supply that has, 1 amp output, 2 amp output, 5 amp output. If you're going to be running 1,000 lights, you're going to want the 5 amp versus a 1 amp. Individual circuit failures don't impact the rest of it, so you can figure out what failed and then just do a component replacement. But there is more wiring, more resistors. And once again, so it's just everything. Each component has its own path to power, so there's no fear of losing everything. Here I made a video, actually, but I'm going to have to do a voiceover because there's no speakers in here. So give me a second here. So we've already discussed calculating resistor value. So in this case, I'm running a 3 millimeter.
The white LEDs are
Oh shit! There's sound.
3 or 3.2 volts, and we're using a 9 or 12 volt power supply, and we're using a 470 ohm resistor to step that down. The first thing I want to do is pre-tin the soldering iron, and that is putting solder on the tip, and it improves heat transfer. But I'll also be pre-tinning the leads of the LEDs, the resistors, and the wires for the same reason, to improve solderability. Before soldering everything together, I trimmed down the positive lead on the LED and trimmed down the lead on the resistor. Once they're soldered, trim the leads a bit more, then solder on the wires. This is all to save as much space inside of it as possible. Once you're done, your resistor LED combination should look something like this.
I don't know if you could hear that back over this. I'll make this available on my socials anyway. So everything will be viewable. But basically the big takeaway from that is very quickly going over soldering. Pre-tinning is super important, and that is getting solder on the tip of your soldering iron, so that when you attach components, you get proper heat transfer. Without it, you'll find that without it, it just doesn't work. And that's why I also did the same thing, is pre-tinned each individual lead. So there's already solder on it, everything combined gives you good flow, everything bonds together. And don't worry about that little guy.
Does it matter where, like, in the length of the wire, does it matter where the resistor is? Like, could I put it at the bottom? You're closer to the power supply than it is to the...
Oh, sorry, I apologize. I'm going to step over it. I actually don't hear so well. It's my fault.
Like, I'm working in really tight spaces,
Yeah.
right? Like, I do Gundams and stuff, so I gotta run wires through really tight areas.
Yep.
Could I put the resistors outside the model, like, closer to the power supply rather than...
Absolutely.
Okay.
I just do it up at the component
Like,
for...
in line.
Yeah, just as long as it is in line,
Okay.
in somewhere between power source and light. Yeah, I don't do a lot of Gundams, but I understand the tightness, the space tightness.
Yeah.
So, sorry.
Is that resistor soldered to the cathode side or the anode side of the LED?
Positive side?
Cathode side?
Yep. Shit, I've forgotten.
No, it makes a difference, doesn't it?
It's, okay, look here. Here's the funny thing. Everything I learned in school about this, I have literally forgotten. I just kind of. So I'm like, wait, which was cathode and anode? Shit. So yeah, on your LEDs, on your 3 millimeter LEDs, the longer terminal is your cathode or positive side. With the SMDs, the small chip ones, the wire's already color coded.
Okay.
So you got red and black, so it just makes it even easier. But yes, to answer your question, as long as it's in line somewhere, put it where you need to so you can work in that space. So I've kind of talked about these already, and that's basically, pardon me, you do have endless creative options. It is important to start somewhere, so once you just light an LED, just light one if you haven't done it before, and that'll kind of get the whole process started, and you're going to look into other components and look at your models and figure different ways to achieve the things you want to achieve. It's, you can do so much with just the basics. Not this one in particular, but the K7 was the first model I ever lit. And I did it with 4 LEDs. Because the way it's made, I just put 1 LED under each cap, and at the time just made window masks out of masking tape. And boom, 4 LEDs, a little bit of wire and some solder, and boom, I lit my first model. And that turned into that, into that, into that, It's like anything. Just make the decision to start. And I know that I know I'm making it sound simple, and Pardon me. What I mean is, come back to what I said earlier, I don't want to say, hey, it's easy if you find it complicated. The point is, once you make the decision to try, once you commit to it, and you get those first few under your, off your bench, then you're just going to look for, ideally, more and more opportunities to do more and more interesting things to make your models shine. Do's and don'ts, save yourself some headaches. Only a few. Plan your circuit before soldering, which is, as I was saying to you, Eric, before we got started, there is another component to this beyond understanding the basics of lighting. It's, you now have to add another element into how you build your models. Most models aren't made for lighting, so you need to look at your pieces and figure out where you might have to remove material, drill channels, whatnot. So planning is important, but it's one of those things, like, once you get the first one laid out, it will become second nature, because you're already accustomed to building and most likely modifying models anyway. Start small, if you've never done it before, just light one. Put one light in something. If it's a case of, let's say, a Gundam, for example, if you're just lighting the eyes, if there's enough room depending on the size of the room in the head to get one LED in there. Always use the correct resistor. And as I said, I've got QR codes at the end of this that you can get all the links for these things, so you don't have to memorize this stuff. But it's important to understand why things are the way they are. This is a big one. Test your circuit before closing your model. Test. I cannot stress enough how many times I have closed a model and then the lights don't work, because either I missed something, or a connection failed, or they arced, whatnot. So always just test.
I'm not thinking, just sorry to interrupt you. The best way to test that is you keep the LED piece open for 24 hours, let's say overnight.
Oh yeah, the
morning, everything works well. That means no one
yeah, there's
some states track groups.
Yeah.
Boy Franklin, always doing that. Always test his circuits on for 24 hours. So he leaves it open for 24 hours, the whole night. If he comes back the next morning, everything's working perfectly. That means everything's working.
Yeah, the burn-in time. They call it the burn-in time.
Yeah,
they call it.
Exactly.
I tend to run, for me, I tend to run them a lot during the building process, so I tend to get those hours in. But regardless, it's important to do, so that if a component's going to fail, let's hope it fails before you close it up. As far as don'ts, don't overload LEDs with too much current, which, now that you understand resistors, is not an issue. I put down don't rush soldering. Bad joints cause headaches later. What I mean by that is that your solder joint doesn't have to be pretty. You just have to make sure your components are properly fused to each other. And once again, don't skip testing. Just keep those things in mind. It's going to save you headaches down the road. And I got a little scripted part here, but I imagine if you're here, most of you might have something in mind already that you want to try. But for simplicity, so I've actually got this out of I got both of them. I got this guy here, which is running one strip of LED tape to do the floor. And this A-wing is out on my table. Each engine just has one SMD LED in it, run by a 3-volt coin battery. So it can be, that's the whole point. It can be super easy, and depending on what you're doing, you can skip resistors altogether. In the case of this one, the coin battery puts out 10 milliamps. The LED runs on 20 milliamps, so I don't need a resistor. I can just connect it, and you simplified the whole circuit. And as I said, the next slide, I believe, has some QR codes if anyone wants to get those. But basically, just do different resistor calculations just to kind of start getting your head around it. Like I said, you can use the online calculator for that, or manually if you prefer. If you get a hold of a breadboard, you can obviously test everything, because all you need is just a little bit of wire and your LED and resistors and your power supply, and you can test them before even doing any permanent connections. Forums and communities are also great as well. Some people recommend Reddit. I haven't really used their over there. Forums or direct communities tend to help. With for example, we have a Sci-Fi Modelers After Dark club. Several of you are here from that club, which is good because you can directly ask someone who might have some experience to help you problem solve something. So, you don't have to go it alone. So I apologize. I had meant to print some stuff out for this, but if anyone wants to grab those, these are the two I use the most. More so the resistor calculator. And the other one is just for being able to look at a resistor and figure what its rating is. But as I said, when you buy them, they're going to be labeled anyway. They come in a little sheet with a number on them, so you're already going to know what you have. But those are good to have anyway. Just let me know if anyone needs that up there anymore. And, oh yeah, there you are. I was like, did I skip something? I reworked this when I added the video yesterday. So, a couple things. You can go to my YouTube channel. I've got videos they're generally integrated into my build videos. I'm probably going to start integrating things like this as a separate video stream on there. I do have an Etsy store. It's still small. I've only got a couple lighting components so far, and some other model products specifically for the sci-fi. But as far as buying electronic components, I'm going to do these in reverse order. As you're getting started, if you want to buy a whole whack of LEDs or tape, Amazon, AliExpress. I haven't used Temu, other people have. You can buy a whole bunch for low cost. I can't speak to their overall quality, but I've never had a failure. Or HJ Model Works is a specialty store online that does they do model kits, but primarily focused on lighting components for models.
There's one, you probably forgot, Evans Design as well.
What's that?
Evans Design.
See, yes, Evans exist. I don't like their components.
No, me neither, but
It's a way.
it depends about what. It
Yeah.
depends about what kind of, you need, basically, you want to have a certain effect you can't find anywhere else.
Yeah. In this case, I can only recommend what I've used successfully. But yes, Evans Design does have additional components. Their component design hasn't worked for anything I need. That's a better way to say it.
Yeah.
Any questions? No? So everyone's fully educated? I succeeded?
Where do you normally park your battery?
What's that?
Your power source, do you put it in the base?
So these ones a combination of either HDA or Amazon if I don't want to wait for shipping out of the US. So yeah, like for example, go on Amazon, they get 12 volt DC power supply, 9 volt, 5 volt. They also come in variable, where there's a little knob you can change it from 2, 3, 5, 7, 12, whatnot.
Like coin battery earlier, do you put it in the model?
So after I'm done, I'll be back at my table. I can show you, but basically, in the base of the A-wing is where I mounted the holder, so you can just slide the battery in and out. Everybody else? No? All right. Well, before I wrap this up, I'm going to plug my own stuff, if you all don't mind. So, if you like this, you should absolutely subscribe to Jason Space Doc on YouTube. I got a lot of good videos. Several of the things that I have on display, I have full build videos on, so you can see the whole process. I did create an Amazon shop before doing this, so anything that I have bought from Amazon that's part of my kit, there's direct links to. And this just goes right to my link tree. If you really like what I do, you can join my Patreon. I do have a tech support section, so you can actually reach out to me directly as part of that. And then there's just a link to my other socials, Instagram, Facebook, TikTok. And I'm constantly adding new stuff. And like I said, after doing this, it's very likely I'm going to produce additional follow-up videos of a how-to, not just the build. However, if you look at my build videos over the last year, they are all broken down into chapters. So if you're curious about just lighting, once you open up the description, you can just pop right to that chapter. Otherwise, I hope this has helped, giving you some inspiration, giving you some ideas. Feel free to, check out the tools and equipment if you so desire. But otherwise, with the basics of this, once you know how to calculate a resistor value, you can start wiring your models. So,
some of you are interested, haven't been to the club meeting, our club meeting on Tuesday, 6:30 p.m. At Hobby Center.
See,
Where?
that's what.
The Hobby Center. Yeah, 6:30 Tuesday.
This is why Eric's my co-administrator of Sci-Fi Models After Dark, because I always forget to plug it. But it's been a good 6 months so far. I think we're coming to meeting 6. We're steadily growing. People seem to enjoy it. We go for a bit more. We try to go for an interactive versus a situation like this where someone's just talking at you. So as we discuss things, you can. Like before, last month, we talked about electrical, and it was more or less a round table where everyone had a chance to contribute or ask questions. So it's a good time. I recommend you all check it out. Otherwise, thank you for coming and watching me stumble through this presentation. And thank you. Oh, look it. I hope more than anything, it gave you some information to start doing this. Or just filled in any gaps you might have.
Yeah.
So thank you, and I do believe that Hank is up next at 11, and he's going to be talking about airbrushing. So yeah, once again, I said thank you for bearing with me, and like I said, I hope you got something from it.